Hi, I'm Ellen Young, and today I'm going to talk about selective treatment of clinical mastitis, current practices, and farm impacts. I'm supervised by Dr. Herman Barkeba of the Department of Production Animal Health of University of Calgary, and I would also like to take this opportunity to thank the National Mastitis Council for awarding me the 2021 scholarship. So I'm born in a town near Rotterdam in the Netherlands, and I completed both my bachelor and master in animal science at Wageningen University. Then I moved to Canada for my PhD at the University of Calgary. But back to the presentation. Antimicrobial resistance is a threat to the dairy industry because it compromises treatment efficacy, causes welfare problems in cattle, and runoff into the environment. We know that antimicrobial use is the main driver of antimicrobial resistance, but the effects of different management practices is still not yet fully understood. So the WHO has compiled a list of antibiotics that are very important for human health, as they are often the last resort to treat certain diseases, such as tuberculosis. So widespread resistance in these antibiotics would be very problematic. So the WHO has categorized these as critically important, highly important, and important antimicrobials. In the dairy industry, the majority of antibiotics are being used for dry cow therapy and clinical mastitis treatments. And more specifically, for the treatment of clinical mastitis, antibiotics are being used intramammary. So these are some of the examples of intramammary antibiotics, their active ingredient, and also their placement on the WHO list. And as you can see, is that most of these antibiotics are actually very important for human health, which is yet another argument for us to limit their use. So how can we actually limit the use? It would be ideal if we were able to select cases that maybe do not require any antibiotic treatment. And to do that, we could use culturing of clinical mastitis milk samples with the aim to select cases where gram-positive bacteria are present in the udder. This is especially important because gram-negative cases don't respond to antibiotics and often occur spontaneously, so they don't require any treatment. And although the udder might still be inflamed, it doesn't mean that bacteria are always present. And this will show as a no growth culture result. And those cases also don't require any antibiotic treatment. So in summary, culturing of clinical mastitis cases can be a tool to distinguish between cases that do and do not require antibiotic treatments. So then we asked ourselves, well, what selective treatment protocols have been described in literature? So there are 6 studies which looked at the health effects of selective treatment protocols, and they all described that they took into account the severity of the mastitis case. So severe mastitis cases did not require any treatment. They also looked at on-farm or laboratory culture results, where they excluded gram-negative cases and no-growth cases from treatment. Very interesting is that they also took into account, some of those protocols describe somatic cell count, milk yield, lactation state, and repeated cases. And that led us to our following question: what factors are actually part of protocols that Canadian farmers are using? So for that, we conducted a questionnaire among 144 farmers in all across Canada. And we asked them if they selectively treated clinical mastitis cases, what factors they took into account in their decision-making, and the importance of these factors. So we found that from a sample population, 59% actually selectively treated clinical mastitis, and this number did differ across provinces, as you can see here on the figure on the right. And although recent numbers are not available, it has been reported in 2017 that 45% of producers in Florida, Michigan, and Pennsylvania selectively treated mastitis, and back in 2006, 22% of Washington state producers. In Northwest Europe, selective treatment is actually the norm because of regulations. So we asked our farmers, the ones that selectively treated, how important do you find the following factors? So we asked them for production of the cow, severity of the symptoms, somatic cell count, mastitis history, suspected or confirmed bacteria, need to fill quota, calm or place cost, age of the cow, and genetics of the cow. So for example, for genetics of the cow, we found that actually a very small proportion found it very important to take this into account, and almost 50% found this not important at all. So this is the complete figure, what we got. And what we saw was that the majority of farmers actually used a variety of symptoms, followed by suspected or confirmed bacteria. But then this makes you wonder, there are probably farmers who use more than one criteria and they use a combination, but are there any patterns that we can distinguish in this data? So this is the underlying data, and every column represents one farm. Although it is a bit easier to spot some of the patterns that might be present, it's still very difficult, and that is where clustering comes in. So in clustering, you allow the computer to look at your data and identify groups that are very similar to each other. So in this case, we start off with a group of very diverse individuals, and the computer found that there were actually 3 different groups present. Some that like tea, some that drank coffee, and some that preferred something stronger. So we did the same thing for our data. So again, this is what we started with. And we actually found that there were 3 distinct groups available in our data, and every farm represents one number here. So each of these 3 groups had a very distinct profile. So the first profile represents farmers that actually only look at severity of symptoms when they decide to treat or not to treat mastitis cases. The second group uses a wider range of other health criteria, including somatic cell count, mastitis history, suspected or confirmed bacteria in their treatment decisions. And the third group actually used a whole wide range of cow factors, including production of the cow, age of the cow, and genetics of the cow. So this is very interesting. And to just summarize, so the gold standard in literature is to treat based on severity and culture results. But in reality, we have these 3 distinct farmer profiles. And it will be very interesting to now identify if there's any differences in actual antibiotic use that they use and what the rationale is behind these decision factors. But for now, we asked ourselves the question, what are the effects of selective treatment protocols? So we went back to those 6 studies that I've described earlier, and they all looked at the health effects of selective treatment protocols. And what their studies looked like was this. So every clinical mastitis case, they allocated it to either a blanket treatment group or a selective treatment group. And they compared these 2 groups in terms of clinical cure, bacteriological cure, somatic cell count, recurrence, culling rate, milk production, milk withdrawal period, number of follow-up treatments. And then they looked at the differences between these 2 groups. And it's actually, it's very positive if we don't see any difference, because that means that a clinical mastitis case allocated to a selective treatment has the same treatment outcomes as one that has been allocated to blanket treatments. So I just want you to take that into account, because on this side I've summarized the results from these studies. So again, the 6 studies and the different parameters that they looked at. And as you can see, actually the majority found no difference between the blanket and selectively treated clinical mastitis cases. 2 did found an increase in clinical cure in the selective group. 1 found an increase in bacteriological cure in the selective group. 1 study indicated that there was on average a shorter milk withdrawal period in the selective group, and 1 study indicated that there were fewer follow-up treatments in the selective group. So that's all very positive, and again, an argument that it's okay for cows to be treated according to a selective treatment protocol. So, and this is the result of their antimicrobial use reduction. And as you can see, there's actually a huge reduction that can be achieved when adopting a selective treatment protocol. It did differ between these studies, and that's because the reduction that you can achieve all has to do with the bacteria that you have on your farm and that are causing your mastitis cases. So I've tried to detail that in this table here below. So in conclusion, of the surveyed farmers, 59% used a selective treatment protocol. And there are different protocols that are being used. But there's no difference in other health and production between selective and blanket treatment of mastitis. So this means that there is an opportunity for reducing antimicrobial use associated with the treatment of clinical mastitis on dairy farms. And I'd like to thank my supervisor, Dr. Herman Barkema, my colleagues, Kaylee McCubbin and Carmen Brummelhuis, and the Canadian Dairy Network for Antimicrobial Stewardship and Resistance for collecting this data. Thank you.